Hello and welcome to Tetrate Tech Talks. Today is Friday, August 12th. My name is Eitan Suez and I would like to welcome you to our episode today. This is episode 16 of the Tech Talks. My name is Eitan and the Tetrate Tech Talks are brought to you by my employer, Tetrate. And they are a live stream where we feature a conversation with a guest and discuss technology, specifically technology around those things that Tetrate works with, and that is service meshes, the Envoy proxy, Kubernetes, and Istio, and much more. So we're happy to have you with us. I'd like to say welcome, and I always like to begin with our landing page, just so that you can follow along with us. So what you see here on the screen is the Tetrate Tech Talks landing page, and the URL for it is also flashing on the screen and should be in the description of this episode. And so today is Friday, August the 12th, 9 a.m. Pacific. I come to you from Texas, from Central Time. It's 11 o'clock. And let's dive right in. Let's go into my little cheat sheet or outline for episode 16. I'm going to make myself a little smaller and make the font size a little bigger. And let's just go through this together as we normally do. So the Tetrate Tech Talks, if this is your first time here, I would like to welcome you, is a live stream where we discuss technical topics around service meshes. The URL is there front and center on the screen. And the objective of these Tech Talks is to create community, to get to know the members of the service mesh community and to learn and share knowledge and above all, to have a great deal of fun in the process. If you have a topic that you'd like to suggest, don't hesitate to bring it up in the comments, bring it up on our Slack channel, which I'll give you the details and the coordinates for it shortly. All right, so my name is Eitan Suez, and just to recap on some past episodes we've had recently. On July the 8th, we had a conversation with Lee Wang, who's a Tetrate engineer, where we talked about many of the concerns working with customers and clients and helping them adopt service mesh. And then we followed that up on the 15th with an interview with another Tetrand. These are a series known as the Tetrand Profiles, where we talked to Michael Acosta-Madiedo. So if you've missed any of these previous episodes, they are all recorded and available on our YouTube playlist and also on our LinkedIn page. So definitely check out the links on these pages. And let's move on. Let's carry on and talk about this episode proper. Today is August 12th, episode 16. And our guest is Aditya Prerepa, which I'd like to bring him on and introduce him. Give me just a second. Aditya, welcome to Tetrate Tech Talks. Aditya is a Tetrand and also a committer on the Istio project. And I should also add, Aditya, that you're about to start your first year at university this fall, which I think is very exciting. I'd like to give you the opportunity to introduce yourself properly. Why don't we start there?
Yeah, sure. I'm Aditya. I've been working at Tetrate since June of last year, and Istio since March of 2 years of 2020. And so I'm going to college this fall. Yep.
That's awesome. That's awesome. So I feel like I need to provide a little bit of context to our audience with regard to how this all came about, right? I think I need to rewind all the way back to an Istio Weekly episode that you did with our colleague Peter Yoshevitz back in October of 2021. And I think the title of that episode was how I got started committing to the Istio project, I think. And I thought it was a thrilling conversation about, and the one thing that stands out in my mind the most is the point you made about how, just looking through the documentation didn't really get you that much closer to really understanding Istio. And you really had to dig into the code in order to properly understand how it worked, and that sort of opened the door to maybe the potential to sort of try this approach. I remember on our Slack channel maybe a month or two ago there was a somebody was making a suggestion. It's like, show us how to do it. And so I did an episode, I think it was our July 1st episode 13, where I went over the basics, like how to set up your workstation, how to check out the code base, how to build it using the make targets that are included with the project, and setting up your IDE. And I also showed something that I think one of the other Istio committers from Google, I think Jonathan Howard, I believe is his name, where he walks you through setting up maybe a local Kubernetes cluster to sort of tighten that feedback loop, where you could actually run IstioD outside the cluster as a mechanism for debugging without having to sort of rebuild new images every time and sort of tighten that feedback loop. So that was a sort of a preparatory episode to, I think, the meat, which is the one we're about to go through right now. I wonder if I'm leaving anything out. Is there anything else that comes to mind in terms of what we should mention before we dive into this demo?
No, that all sounds good.
Okay. All right. So just like we did with episode 13, what I asked Aditya to do is to pre-record. What you're going to see is essentially Aditya walking you through probably one of the most important sections of the code base. And what we're going to do is play it. And it's about a 20-minute recording, give or take a couple of minutes. And once it ends, we're going to then come back online and discuss many of the things and take the opportunity to answer any questions that you have. I see that we also have Maciej with us. Maciej was actually the individual who actually had asked to see episodes that dive into the code. So welcome, and I'm glad you have the opportunity to be with us, Maciej. All right, so without further ado, let's go ahead and play this episode. We're going to be on the sidelines. Maybe we'll make ourselves invisible. We'll come back afterwards.
Hello. So I'm going to be going over the ADS interface that Istio uses, or like the one that Istio implements, to connect to envoys and configure the proxies. This is what's currently being used, and it's like the standard. It's really robust, and it's been like battle tested a lot. So you know that in production and everything. So you know that this is the Istio ADS implementation is something to be reckoned with for the most part. But yeah, so we're just gonna walk through this and try to get a sense. I've been through this before, but I'm just gonna walk through it as I would, knowing this stuff. Yeah, so I'm just going to walk through it and hopefully give you guys a sense of what going through the code should be like, especially in a code base as like sophisticated and like large as like Istio. It could be hard for I remember the first time looking at this code, it was kind of intimidating because I had no idea what anything meant. But you know, you're going to find that doing a lot of go to definition and go to implementation will bring you a long way, and then like a lot of cross references to the documentation. And yeah, we're also gonna play around with the actual. We're actually gonna start. We're gonna make some changes and then compile them and like see them actually work and changes work, and then like basically you'll get like an entire cycle of like development, or what that looks like. So first, like okay, so for a little bit of background, ADS is the Aggregate Discovery Service that. So ADS itself is a protocol that Istio implements, and Envoy also uses. So when Envoy connects to a control plane, it expects, you know, a certain ADS is one of the protocols you can use. That basically means all the resources are like all the types. There's like secrets, there's, you know, clusters, listeners, routes. All these things are like condensed into one singular stream. Whereas the other variants of this are like there's like a Delta version, which sends like the changes, and then there's also like individual like streams for each resource. So there's like a CDS stream, an RDS stream, so on. But Istio implements like a singular stream ADS, which is like aggregate. It aggregates all the stuff. But yeah, so this is actually okay. This is ads.go. I think you can see this. This gives us like the base interface. This is like somewhere, let's see, it's in the pilot module package XDS. There's like tons of files here. So and like getting through all these can be a little hard. So this, you can see here, this is like CDS. This is specifically for clusters. This is for like endpoints. This is for listeners, and so on. But yeah, this is where the meat of the sending and receiving actually happens. So yeah, so actually what we're going to do is, when you're starting with this, you're going to be like, what do I do? You're going to notice that this is a gRPC implementation. If we go here, we get to ADS dot, what I did there was a controlled bead, which in Golang, JetBrains does a really good job of like structuring. You can like basically go to definition really easy. So for me, that's just control B, or you can control click, and you can figure out, this is actually a gRPC interface. And you're going to see, okay, yeah, so this is a generated file. Clearly there's some stuff here. And if you're looking at this for the first time, I encourage you go to like, the like Envoy, XDS, API, like that, that documentation. This does a really good job reading it. That's if you're going through it for the first time. It's like, okay, what even is XDS, like, or ADS? Like, what is the point of this stuff? But yeah, so this we'll see that this is a generated, it's a gRPC interface. So from a gRPC interface, if you ever used it, you know that you get like stubs to implement. So let's look for those stubs. If we can actually go down to the usage, is like, let's see, discovery stream. We see the two usages. There's a stream and stream aggregated resources. So okay, let's see. Or this is the actual thing, but this right here is the implementation of the ADS interface. And this is just general gRPC stuff. But we can actually go to the interface that is generated here. And so whenever we implement ADS, we're expected to fill out these stubs, basically create a struct that has these methods and implement this interface. So let's go back to the implementation. And we can see that, okay, it just goes to this method here, where it just gives a stream. And so this is the actual meat of the stuff. So let's go through this. So a lot of times you're going to have to cut out, like, this doesn't really matter to you if you're reading this for the first time. This is just some implementation specific stuff. Even this is like, okay, this is some authentication stuff, but the real thing that matters is like, okay, so what we're seeing is there is a new, so when this method is called, there's a new connection to the control plane because it wants a peer, or like an envoy, wants the control plane to stream resources to it. So we have a connection object here. We can see this. This is like the first important part, where it gives you the peer address, which we set above here. We get this peer address from like the context of the stream, and then passing the stream. So let's go see. This just spits out a struct that has a bunch of stuff, and a lot of this is multi-threaded, or like there's like multiple go routines in order to optimize like sending and receiving, so that it's not all blocking, so that like you can send multiple like connections at once and get timely responses. So that actually makes it a lot more tricky. If you were just to make it like single threaded, like all the generations on one thread and like receiving the stuff, you wait for something to be received, generate and respond. That would be a lot slower than what's going on now, which makes it harder, but that's not a bad thing. So yeah, this creates a new connection object. Remember, it's not actually doing anything. It's just creating a connection object. And what we're doing here is a go receive. This just means that, there's a separate thread, and we can actually look. And the comments are really useful. Block until either a request is received or a push is triggered. So what does this mean? You see this, it's like, oh, this doesn't block though. It just creates a new thread. But you can see that this right here blocks. This is waiting for an object in a channel, which means this will block until, I'm assuming in this method, an object is passed to, yeah, okay, so you can see here, it's going to wait until, it's waiting until the first request, or for a request. Yeah, so, okay, here we go. There's a bunch of logic here. It's kind of like, okay, so you have, checking if it's the first request. This is a infinite for loop. It's asking, okay, so receive an object from the stream, and then if it's the first request, This is health checking. This is kind of like not. I'll say a lot of this stuff you'll figure out like as you're reading the code. A lot of it's like edge cases. Like so that actually kind of makes it very hard to understand at first read. But there's only like a few lines of actual like meat that get called most of the time. So like here that would be like, in a connection, and then like what this does is it literally passes this back into the request channel. So what this does, this receive method will take the stream, receive an object, and then pass it into a channel. And this is run on a separate thread, like assuming. So yeah, and this does a bunch of logging and stuff. But the main point is that all this does is receive, along with some other stuff, edge cases. So yeah, so this is like the meat. Request is here, and then it selects and then passes it back. And this request chan is in the connection object, and we're getting a pointer here. So that means we share this object somewhere. So we'll get, here it is, request chan. So you see here, I can actually split this. If you go to receive, this is being done on a separate thread. It receives here, and then it passes into the channel here, and then that comes over here basically because this is on two separate threads. This is selecting in a forever loop or for loop. So this means okay, we'll get it here whenever it's received. Okay, that's good. And then so basically we're saying as long as we get something from the channel and it's not like garbage, we're going to process this request. Otherwise, there's something wrong with the channel. And then after that, so yeah, let's go to process request actually. Yeah, so here is where the actual like stuff is happening. Process request just returns an error. Well, let's see. Yeah, so as you can see, process request, it takes in the request and then it does a bunch of checks. Like, it doesn't really matter. It's asking, okay, like, should we respond to this? Like, and there's a bunch of like niche checks there. Let me close this out. And at the end of it, really what it's doing is it's giving back what, like it returns an error, but so okay, here's the thing. This is a gRPC stream, which means it's not like a synchronous like stub like request response. What's going to happen is it's going to call this method here, push XDS. So what all this is doing is just crafting context around this proxy and like the resources around it. So this should respond method, if we look at it, it's like saying, okay, like if the last error detail is not nil, we're going to return false, which means like we shouldn't respond. If this was an unsubscription, we're going to also not respond. But we do respond if there is like this is like I think this is like when Envoy first connects, or yeah, when Envoy connects the first time, or it's Envoy reconnects. So we always want to push then. So then that means we do respond. And yeah, so this is basically and so this resource delta thing didn't exist until recently actually. But yeah, this used to not exist. It would just return true or false if it should respond. Yeah, this resource delta basically says, okay, this is the difference from the last like request. As we can see here, we actually keep a log of this previous resources and request our resource names. Like this is set every single time a request comes in, and it's thread safe. But yeah, so then this is how we figure out if we should even respond to a request. Okay, and if we shouldn't respond, we just return. We don't even push anything, right? This is the meat of actually pushing resources to Envoy, which is what it wants. So if we shouldn't respond, just return. Otherwise, create a push request, and figure out the context around the proxy. This is just some custom logic to compute proxy state. And then finally, we push XDS here. And this is where actual compute configuration, like a configuration compute happens. So everything until now has been, we're looking at this later, but everything until now has just been kind of in this method, right? Stream, so not so bad. Yeah, this is kind of the same thing. If there wasn't a request, pull for requests and pushes. yeah, so this is like, but this is actually the meat of the stuff. This processes a request, and it selects on a channel. That's it. So actually, let's go outside of this. Let's figure out. Let's figure out where this is actually being called. Like, what is this implemented for? So if we look here, this is implemented to discovery server, which means this struct implements the gRPC ADS interface. So what we should do is we should figure out where these usages are. And so if you're doing this for the first time, you'd probably have to figure it out. Like, I mean, you can probably tell that it's probably not going to be in ADS, probably not going to be in Delta, and it's probably not going to be in any of like the EDS or like this stuff, right? It's going to be in a pretty generic file, but like I know for a fact it's in discovery.go. So we can actually, or a better thing to do is actually to go to the constructor. Go to it's like the method that creates the struct. And like the constructor of the struct, I guess. So this. And this will actually give you the official usage. The rest are like kind of unofficial, I guess. The official creation of this struct. So yeah, this, we should check where this is called, and then we can see that, okay, server.go. This is where the actual server is being created. So new discovery server, this discovery server implements the ADS interface, and we're just setting it to s.xds server. What is S? We can like go to the definition of that. Okay, it's the server. And this server, what is this? Okay, this is a new server thing. Let's go to where this definition is, and we can tell, okay, cmd.go. Usually in Cobra stuff, the root command is just cmd.go. So let's see. Yep, you're right. And we can see whenever you do istioctl discovery, or it's probably a sub command actually. Let's see. Oh yeah, it's a pilot discovery. Whenever you call that, the server is created, and that means that the ADS interface is exposed. So if you follow this all the way down, you can figure out what the implementation looks like if you follow it through the stack, which is a good way to figure out how stuff works. That's like, I mean, there's no like official. This is the only way to do it basically. So yeah, let's go back to new server, and then we can check. Okay, so XDS server, new discovery server. We can go to discovery server, and then we can go down to where you know. Okay, so this is going to be a little bit. It's going to be in stream. Where is it? Stream. Yeah, we know it's in stream resource. We know it's here because we know this implements this. So that's how we can follow it up in the stack. And so let's go actually to the XDS pushing. Again, so it's in process request. Remember, all we do here from this point basically until this point is we just receive a request, and we hand it to a method called process request, which figures out what to do. And this process request thing, it does one of two things: either returns and doesn't push, or it pushes. And so this is returns and doesn't push, and this is pushes. So this is the interesting part. Let's go to push XDS. This is where, like, you know, like everything up till now, that was just like setting up for this, basically computing a state. So yeah, essentially we can basically, okay, so a little thing about Istio generation. We use the generator model, which is like based on the type URL, which is like the resource envoy is requesting. We're gonna find the generator for that. So if it requests the cluster, like which is like this type URL will reflect that. Then we will actually look for. Okay, we're gonna look for, and this is a different file. This is xdsgen.go. So we're gonna look for the cluster generator if it gives us, you know, the CDS type URL. So let's go to this method, and yeah, we can see that. Okay, it goes through all the generators. It's just there's a generators map, and that gives us, you know, the generator, and it just this is like the main thing. If we go to the generators and we go to where this is set, let's see. Yeah, so here, this is like the main. This is where all the generators are set, and from here we don't even need to care about the other stuff anymore. Like this, after we have seen this, we don't need to care about the rest because this is where the actual resources are being generated in the generator. The rest of this stuff is just like edge cases and like, you know, constructing the response. Yeah, this sends it, and then that's it. So we can see here that the resources, if you go to res, gen.generate. So all of the, you know, all of the meat of the generation exists in the generators. So let's go to the generators now. Yeah, so now there's all, so this is how we like break down the custom like generation logic without going like if type equals cluster, then do this. If type equals listener, we have a map of generators to a generator like type URL to generator. And so yeah, we can go to this. This is the one that's I think the most used CDS generator. This generates clusters. And yeah, so this generator actually implements an interface. If we go here, it's an XDS resource generator. This is also something, but yeah. This right here is a default interface for all generators. We can actually see in this, if we go to the generators thing, XDS resource generator is the type of the map, so it's not actually any specific struct. It's just like an interface. So if we go to the interface implementations, we're going to see all the generators here. So back to CDS generator, we can see this is some custom logic to see if we need to push a cluster. And then this is like where the ADS, state of the world ADS generation happens. And so we can see here, there's one method, build clusters, right? That's the main thing. And we're going to go to that, and that returns clusters given the proxy and the request. So we can tell this is where the meat of stuff is happening. But we see another interface, which is interesting. What's happening is that here, the c.server.config generator.build clusters. If we go here, this is a core.config generator. This is like another layer of abstraction. There's so many layers of abstraction here. So we like all like doing in like a large code base, all you're doing is just trying to get to the bottom of the abstraction, basically. But yeah, config generator. This basically could build listeners, build clusters. So this is LDS. This is CDS. If we go down to the only implementation of this, there's just a config generator implemented. And so you might think like, why not just use this directly? That's a good question. I can't imagine when we would use it. Like, so okay, the argument for this before was like, okay, the reason to abstract this away is so that you can have multiple config generators. And the only time that this was actually relevant, I think, was when like the Delta XDS, the first implementation had with Delta XDS, it's a separate type of XDS, and like those two things, like they have different generation logic. So it makes sense that you would use a different config generator there because you're generating deltas, not state of the world. But instead, what happened was we actually, instead of adding a new config generator, we ended other methods. So they build clusters, which is state of the world, and build delta clusters, which is just deltas. So then that argument went away. So you ask, hey, why can't we just have one config generator? I don't know. It's a good question. Maybe in the future there's going to be more. But right now there's just one. So if you go down to the interface implementation, there's just this. It makes it a lot easier though. But yeah, if you go to config generator implementation, and we go to the cluster definition, this is where the actual, let's see, clusters is called, yeah, so if we go up, this is what we're talking about, and then if we go down, this button here is very useful. It brings you up and down the interface implementations. But here we can see, okay, this builds the cluster. This is like the default implementation for building clusters. So essentially, when you call ads.go with a cluster type URL, what it does is, eventually it goes down to push XDS, it finds the cluster generator and generates for that, right? And so you gen.generate, generate goes down to CDS generator right here, because that's the generator that was set in discovery.go. And then this config generator is this just, this thing. And so when you build clusters, it goes down to the only implementation and it does this, right? And then it just config gen.build clusters, and that's just some internal stuff. And then this gets a lot more complicated now. I think I'm going to stop here. But essentially, what I just showed you was from the top of calling the command pilot discovery, all the way down to where the clusters are being built. And like tracing that up and like down the stack takes effort. And like, just remember, like when you're doing this, if you like choose to, I think this doesn't apply to Istio only because of any large code base. Like don't get discouraged by all like the extraneous stuff. Like I showed you, like there's so much stuff that like is not the meat of what's actually happening. There's edge cases and stuff, which is like all treated the same in the code. So when you're reading, you're like, okay, I have to understand every single thing. It's not the case. If it doesn't look relevant, you just move on until you find something that actually makes sense. If that makes any sense. So like right here, this is a good example. Like health info type. This is like we hacked the Istio ADS stream to also support health checking. Not the best design, I think. I was part of the implementation, but I think this would be very confusing to anybody who reading this first time and goes to the onboard documentation. Like, what the heck is a health type? But it was actually some internal Istio design that made it so that virtual machines could health check. Point being, don't get stuck on stuff like this. If you don't understand it, move on. And there's just two main things, like in this function even. Receive, hand it back to the main thread. That's it. Yeah, so just, keep going, keep pushing through the code, no matter what. Okay, all right, good luck in your endeavors.
Okay. All right. Well, that was the recording. That was the demo. I really appreciate it, Aditya. But it's not the end of the episode. There's lots of questions. I watched this kind of in asynchronous fashion, and I think it's probably going to help you a lot more if you pull up the code base, locate the section of code that Aditya is walking you through, and maybe pause and play as and then as you learn that section of the code base, you will, I think, get a lot more out of it. So Aditya, I've got a bunch of questions for you, and let me start by maybe with a comment. I really like, from experience, I also know that this is a skill that's really important to develop, which is the advice you give about when you read the code, the first thing you have to do is distinguish between essential paths inside methods and ones that are extraneous, like you mentioned. You call them edge cases, where it's okay to completely gloss over them. And developing that skill, understanding exactly the context that you're interested in and what path to follow. There's sort of discerning the noise from the essential parts, I think, is really wise advice.
Thank you.
Yeah. So the other, I think, a big takeaway for me is on the importance of using an IDE. Now, that's always a very personal choice. There are people who really leverage their knowledge of a particular environment, whether it's VS Code or Vim or in this case Golang. I'm a big long time. I used to do a lot of Java development, so I used to be a JetBrains coder, and I've pondered on this question. I'm curious what your point of view is here. I think maybe the IDE doesn't matter so much when you're working with a fairly small code base, but when you're working with a large code base, it, I think, could make a huge difference. Do you agree?
Yeah, I totally agree. Especially so, I think when you're doing small pet projects, like firing up Vim is not hard at all, and I do that myself. There's no point in creating a very large JetBrains project if it's just a pet project. But if it's something like Istio, or if the project is big, you're gonna really appreciate features that the IDE has to offer at scale, because you can navigate around a lot easier, and you can run specific parts of the code and stuff like that. JetBrains also lets you refactor names and functions really easily, whereas in Vim, a find and replace won't really do it. So yeah, that's kind of my take on that.
Yeah, and my advice is also to invest the time. If you don't have that expertise yet with Golang in this particular case, develop it. I think it'll pay back in spades. The IDE pre-indexes everything, so you can almost treat this entire code base as a single large file that you can navigate at will if you know sort of the keystrokes that allow you to navigate through relationships right in the code.
Yeah. And then one other thing is that Golang isn't free by default. I'm pretty sure. I think it's paid. But yes. If you're a student, or were a student, I guess you can use GitHub Student, the developer pack, and they give it to you for free. So just a heads up.
That's wonderful.
Yeah.
I did not know that. So that's really good advice. So if you're a student, there is a way for you to obtain a license for free. Is that what you said?
Yeah.
Okay. Well, that's super. Yeah, so navigating from one method to another, looking at usages of a method, navigating to a type. There was interface versus implementation navigation. You get all of that, and there's ad hoc navigation. You can go to a type, you bring up. I think it's depending on your environment, the shortcut is different, but you can look up a type, and it'll take you directly to it, irrespective of what file it's in. Now in Go, what I learned about Go is that it's much more flexible in terms of your choice of where to place a function. Doesn't have to be all in the same file, and so the IDE will help you there in terms of not worrying about what particular file it's located in, and then just using its navigation capabilities to go to the method that you're looking for. I'm curious. I couldn't quite tell from just looking at the recording, what operating system were you using there?
I'm on Ubuntu 22.04, I think.
Okay.
Always been on Ubuntu, never switched off.
Nice, very nice. Okay. I guess as another data point, loading the code base in macOS works just as well. Although I've personally found some issues with the ARM platform. I think they're, but not so much with compiling the code. That works perfectly fine. But maybe when you're trying to stand up a local cluster, there may be some points there that it might be easier to go with an Intel-based Arch. Are there specific tools? So obviously you have to have Golang, the language, actually installed on your machine. That goes without say. And in this case, our IDE and the code base, which we pull from GitHub. Are there any other specific tools that you, as you set up your environment, that you really think are important to mention, that are essential here?
I think so. You got to have like a local cluster, obviously. Kind is really good for that. I've used like Minikube, Kind, all those, but Kind seems to be the best one. And besides that, like technically that's all you need. Although I think might help to have well, yeah, I guess technically at the base level, that's all you really need. That's like on a database, that's technically all I use. Golang, and then like you gotta have like a good, like, I think it's important to have a good like Vim setup as well, to edit files here and there. But besides that, like, yeah, that's it. And then like have like sometimes Tmux helps for like running jobs in the background. But yeah, that's basically it.
Right. Yeah, and I think the little things, or the things you stumble upon, you can just consume on an as needed basis, right?
Yeah.
So yeah, I agree. All right. Okay, that's good. All right. So the biggest topic of conversation that I sort of want to focus on is it's an artifact of the realization I came to, that you can't sometimes just jump into a code base and expect to be productive on day one. It's never a linear process, right? You always learn something. So, I don't know much about, in this case, it could be the IDE. So you might spend some time learning the IDE, and that then helps you get a little bit further. And I guess the same thing could be said of other things that I think are really important to know with respect to working with Istio. And so I've got a long list of things. I think they're all fairly logical, nothing too difficult to discover. So the first thing I think that from your demo that comes to mind is the relationship of Istio to Envoy, and the importance of knowing Envoy, and specifically the fact that you can configure it in multiple ways. So I think you show the page on the Envoy proxy website, which I think is very, very important to understand, is you can configure Envoy with YAML. You can just write a configuration file and place it in a directory and tell Envoy to consume that. But here, what we learn is that Envoy is configured via API using the ADS API. And so it connects to Istio, and Istio is actually sending it configuration over the wire, which is kind of a cool thing and an important thing for somebody who's new to really understand. So I guess anyone out there wanting to learn this, expect to spend a little time understanding exactly how Envoy can be configured in this way. And that brings us to the other, so the gRPC is really important. And so you might want to look for resources for understanding and learning gRPC. There's plenty of them out there, and that goes together with protocol buffers. So you want to understand gRPC and protocol buffers. So before I continue down my list, I want to give you a chance to maybe itemize the things that you think are most important to know.
So just for Istio, you mean? Like
yeah, like what are the things that you've sort of had to sort of go back and learn better in order to be able to work with the code base more effectively?
So obviously Kubernetes is very important. Like learning how Istio sits on top of Kubernetes and how it uses some of the constructs. How it implements custom resources. Like all the main Istio CRs, like destination rule, virtual service, all this stuff is built on top of Kubernetes. So that's important to understand how that works. I also think maybe Kubernetes, like how like Kubernetes doesn't have the concept of like networks, I think, whereas like Istio does. So like learning how that kind of interacts with each other, and then also like when you bring up your default deployment of like Istio, it'll like create a namespace like Istio system, and then like do a bunch of stuff there. Like I think learning what it does there is pretty interesting. Like it installed an ingress gateway, and like Istio-D. Those are all running as like pods, which is like it's useful to understand that relationship, so that when something goes wrong, you're like, oh wait, technically it's just a pod. It's not like some magic internal thing that's going wrong. It's just a request flowing to a pod or something. So yeah, Kubernetes is important to understand.
So yeah. So I made my own list. So if you know Golang really well, you're good there. But some of the things that jumped out from the demo, of course, is understanding Go routines and channels. That whole concept is very important. You'll come across it. So it's important to understand exactly to be able to at least interpret what you see when you read the code. I guess understanding make wouldn't hurt, because there's a make file there that helps you build the project. So having a basic understanding of make. And so I'm glad to hear. So a high level overview. So reading the docs, understanding the custom resource definitions. That's you mentioned that already. Now, what about conventions? I was really it's one thing that sort of jumped at me when I first started working with Go is you see, for example, this PKG directory in there, and it seems like a convention. That's where you're going to find most of the code, at least the library code. There's a CMD folder usually that highlights, okay, that's where you'll find the entry point to the CLI. That now in Istio, there are multiple CLIs. There's the pilot discovery, there is Istio Cuddle, and I guess pilot agent. I think those are the three. And you mentioned Cobra. So would you expand on what exactly Cobra is to those who may not know?
Yeah, sure. So Cobra is it's a library. It's a Go library that like allows you to easily write. I wouldn't actually say easily. It's like it allows you to write. Yeah, yeah. It's very feature. It has lots of features. It allows you to write your command line tools by providing like command objects, and then you like basically register all of them in the main function. Cobra is useful. I used it for so I've learned about it through Istio, and then I'm working on another project at Tetrate, which is the Istio cost analyzer, and I just used Cobra right out of the gate there, because that's like the standard for everything. Yeah, so Cobra is useful.
Yeah, especially if you're going to write a command that takes subcommands, and then you need to sort of be able to deal with the branching of how the implementation of a subcommand. That Cobra is going to help you there, right? Yep. Now, there's one thing I want to share with our audience. This is not the end of the story. There's one area I think that's really important to maybe demo, and I don't know if we'll have a chance to bring Aditya on or another Istio committer, which is to how we work with the automated tests and unit tests. I know that's something that you originally mentioned was it's a great way to sort of learn sort of the very small and discrete parts of the code before you sort of walk up the stack. And so we'll probably have another episode that focuses on that, on unit tests, reading the tests, running them, and learning as a sort of a byproduct of going through such an exercise. But what advice do you have there in terms of the basics of unit testing in Go? I know there's a matchers library I came across called Go Mega that is used in some tests, but that's not so difficult to internalize, in my opinion. I also came across another one called HTTP test, which is kind of a built-in helper for testing like HTTP server handlers and things like that. So I guess just like with everything else, when you dive into a world, you're going to have to become sort of familiar with all of that ecosystem, essentially, and all the libraries and helpers others have already developed that you can then leverage instead of writing everything yourself from scratch. Okay. All right. Well, that's it. I find this fascinating. I really appreciate you putting together this demo. And again, I urge our audience, if you're out there and you're trying to understand the code base, I think this is a very ideal choice of an area of the code to understand, because it's sort of so central to what Istio does, which is push configuration to Envoy. So the recording will be there for you to consume, and I hope it helps you along as you try to learn Istio on the inside. Aditya, I really want to thank you for putting this together and for coming on. And again, if there are any last-minute questions from the audience, don't be shy and ask it before our episode sort of concludes. All right. Okay. Well, I'm going to continue with the usual sort of back matter that we have, and maybe I'll ask Aditya to stay on for just another minute or so. I tried to collect some of the references from the demo and a few other ones here on our landing page. So again, the link to the main Istio repository, that goes without say. That's pretty easy to find. If you want to learn about the Golang IDE, the link is there, and the link to the XDS protocol in Envoy is also captured there. So if you need it, the link is there. If you want to learn about the Cobra framework, the link is also provided there. This is specific to Go and working with CLIs or building command line applications. If you want an introduction to gRPC with Golang, I found a very apropos link there. And I came across a book by the Pragmatic Programmers. Now, this has nothing to do with Istio, but I think it might be a good reference just to kind of get the hang of how distributed apps are generally built in Golang. And I came across this Pragmatic Programmer publication called Distributed Services with Go, which I'm personally in the process of going through. Again, this is not related to Istio, but could actually in some way help you understand some of the code as you read through the Istio code base. Okay, I think that's it. Though I think we already mentioned that we're thinking about doing a third installment on learning Istio from the inside, looking at specifically at automated tests. So stay tuned for that. I also want to mention to our audience, we're probably going to lower the frequency a little bit of future episodes. We're probably not going to be doing them weekly going forward as we work on some other things. But stay tuned and stay tuned into to our channel as we announce more episodes. And I usually like to close with a mention of our certification exam. Tetrate is the only offers the only certification exam for Istio that's out there, and it's very, very much in league with other certifications you're familiar with, the CKA and CKAD. It's not a rote type exam. It's one where you're given a full environment in which to solve problems over a period of 2 hours. We actually dedicated a past episode to giving you a little bit of an orientation to it. But if you're considering, if you've had time to build up experience as a developer or an operator with Istio, and you think you're ready to get your certification, definitely check it out. And we also have free courses available on the Tetrate Academy that will help you along. And I should mention our Istio Fundamentals course. This is something not many people know. When you complete this free course, you actually receive a 50% off coupon for taking the certification exam. And what I'd like to do is, on top of that coupon, there is an additional 30% off you can gain by using this coupon code, which I'm showing on the screen. So, the cost of the exam is really not an excuse for not taking it. So take advantage of it if you can. And finally, I highly recommend that you participate in the conversation and join our community Slack organization if you have suggestions for future episodes. We're all ears, and we would love to hear from you. All right. Well, thank you for your time. And I want to say again, thank you to Aditya for giving us this demo and talking to us about how he codes with the Istio code base. And we'll see you in a future episode. Bye, everyone.